Indian solar missions' new findings throw light on enduring sun mysteries. Summary: Aditya L1, India's first solar observation spacecraft, has provided important clues as to why the exosphere, the corona, one of the Sun's greatest mysteries, is much hotter than the Sun's surface, and how it maintains such high temperatures while constantly releasing massive amounts of energy through powerful explosions. A research team led by Professor R. Ramesh of the Institute of Astrophysics in India, IIA, published these findings in the prestigious journal Astrophysical Journal Letters. The temperature of the Sun's core is approximately 15 million degrees Celsius, while the photosphere, the Sun's surface, is about 5,500 degrees Celsius. Surprisingly, the corona, located much farther from the core, reaches about 2 million degrees Celsius and sometimes heats up to 40 million degrees Celsius. This extreme temperature difference has long been difficult to explain using conventional physics. The corona is also the source of powerful solar activity, such as solar flares and coronal mass ejections, CMEs. When a CME occurs, massive amounts of energy and magnetized plasma are released into space. The Sun typically generates 2 or 3 CMEs per day, but when activity peaks during its approximately 11-year cycle, more than 10 CMEs can occur daily. While CMEs create beautiful auroras, powerful CMEs can also trigger geomagnetic storms that paralyze power grids and affect communications and weather satellites. Scientists have identified 2 major mechanisms that supply energy to the corona. The first is wave activity caused by boiling motion on the Sun's surface. These waves travel outward, transferring energy to the corona. The second is related to entangled magnetic field lines in the Sun's atmosphere. As these magnetic field lines twist and reconnect, massive amounts of energy are released. This magnetic activity is particularly strong around sunspots and is closely associated with CME explosions. Using observational data from Aditya L1, the research team was able to estimate the amount of energy supplied to the corona through each mechanism. The results revealed that waves generated by solar surface motion provide only about 7% of the necessary energy, while the remaining 93% comes from the reconfiguration and reconnection of magnetic field lines. The team focused particularly on the very powerful coronal mass ejection, CME, that occurred on August 5, 2024. According to Aditya L1's VELC, visible emission line coronagraph data, about 10 hours after the CME occurred, entangled magnetic field lines returned to their original forms and reconnected, helping to restore the corona's energy. Therefore, this study suggests that while waves generated by solar surface motion play an important role, they cannot supply sufficient energy on their own. Instead, the breakage and reconnection of magnetic field lines appear to be the primary energy source keeping the corona extremely hot. The researchers believe these findings provide an important benchmark for studying how energy is generated and transferred in the Sun's atmosphere. Observational data from Aditya L1 could help scientists solve long unanswered questions in solar physics and better understand the impact of solar activity on Earth and space weather. Thank you for watching.